Electronegativity is the ability of an atom to attract the electrons in a chemical bond. Electron affinity is a measurable quantity. Chloride has the highest value. Remember that electron affinity is adding an electron to make the anion. Electronegativity is a relative scale, devised by Linus Pauling. Fluoride is the highest. Here's a table showing you the trends in increasing electronegativity. Electronegativity increases as you go up a group and as you go from left to right in the periodic table. You can classify bonds by the difference in electronegativity. If there is no difference, the bond type is pure covalent. If the difference is greater than or equal to 2, the bond is ionic. If the difference is between 0 and 2, the bond type is polar covalent. Classify the following bonds as ionic, polar covalent, or covalent. The bond in cesium chloride, the bond in hydrogen sulfide, and the NN bond in hydrazine. Looking up the values for cesium, 0.7, chlorine, 3, the difference is 2.3, the bond is ionic. Hydrogen is 2.1, sulfur is 2.5, the difference is 0.4, polar covalent. Nitrogen is 3, the difference is 0, the bond is covalent. To write Lewis structures, you first draw the skeletal structure. You connect the atom with a single bond. Put the least electronegative element in the center. Second, add up the valence electrons. Add 1 for each negative charge, subtract 1 for each positive charge. Third, complete an octet for all atoms except hydrogen. Hydrogen can only have 2 electrons around it. If you have too few electrons, use a double bond or a triple bond when necessary. We will do plenty of exercises showing how to write Lewis structures in class. There are 2 possible skeletal structures for formaldehyde, the one on the left and the one on the right. Let's use the concept of formal charge to decide between the 2 of them. An atom's formal charge is the difference between the number of valence electrons in an isolated atom and the number of electrons assigned to that atom in a Lewis structure. Formal charge is equal to the total number of valence electrons minus the total number of non-bonding electrons minus 1/2 the total number of bonding electrons. The sum of the formal charges of the atoms in a molecule or ion must equal the charge on the molecule or ion. Let's do an example. The structure on the right has carbon with 4 valence electrons, oxygen with 6, and each hydrogen with 1 for a total of 12 electrons. There are 2 single bonds. Each single bond has 2 electrons. That's 4. 1 double bond, which is 4 electrons, and 2 lone pairs, another 4 electrons, a total of 24. The formal charge, again, is the number of valence electrons minus the total number of non-bonding electrons minus 1/2. Let's apply this. First for carbon. There are 4 valence electrons minus 2 the number of non-bonding electrons minus 1/2 the 6 electrons in bonds. This evaluates to be minus 1. The formal charge on oxygen, 6 valence electrons minus 2 number of non-bonding electrons minus 1/2 the 6 for a formal charge of plus 1. This structure, again 4 valence electrons for carbon, 6 for oxygen, and 1 each for the hydrogen. The bonds, 2 single bonds, 4 electrons, 1 double bond, 4 electrons, and 2 lone pairs, another 4 electrons. Let's calculate the formal charge on carbon in this structure. 4 valence electrons minus 0, the number of non-bonding electrons, minus 1/2, 8, gives a formal charge of 0. The formal charge on oxygen, 6 valence electrons, minus 4, number of non-bonding electrons, minus 1/2, 4 in bonds, for a formal charge of 0. This structure is more realistic since it has the lowest formal charge. This is a picture of what the molecule looks like. For formal charge and Lewis structures, number 1, the neutral molecules. For neutral molecules, a Lewis structure in which there are no formal charges is preferable to one in which the formal charges are present. Lewis structures with large formal charges are less plausible than those with small formal charges. Among Lewis structures having similar distribution of formal charges, the most plausible structure is the one in which the negative formal charges are placed on the more electronegative atoms.